Next topic of discussion is skewness and kurtosis. After dispersion, after doing all the method of dispersion, absolute and relative measures, in which we have also discussed the numerical part of various types of relative and absolute measure of dispersion, which are range, quartile deviation, mean deviation, and standard deviation. Now, after dispersion, we will uh, cover the next topic, which is skewness and kurtosis. So, these two terms So these two terms, basically skewness and kurtosis, are two statistical measures which are used to describe the shape of probability distribution. Okay, probability distribution means the distribution of mean, median and mode, such as frequency distribution of data point. So basically, this skewness and kurtosis provide insight into the distribution departure from normally, and it helps in understanding its characteristics. So first of all, let's discuss skewness and its type and its measure, and also its advantages and disadvantages. We will discuss all these topics of skewness. So what is skewness basically? So skewness is a statistical measure that describe lack of symmetry in a distribution of data. Okay, so as skewness, or you can say lack of symmetry, is an important statistical technique that helps to determine the systematic behavior of the frequency distribution. Or more precisely, you can say that the lack of symmetry of tails, both left and right of the frequency curve. So a distribution basically, or a data set, is systematic, symmetric if it looks the same on the left side and on the right side of the central point. So, if we have to tell the measures of skewness, so the direction and the extent of skewness in the systematic, or you can in the symmetric distribution, the mean, median, and mode, these three are identical. So the more the mean moves away from the mode, its mean there is a larger the asymmetric or skewness in the data. So from this we can understand that skewness is the measure of symmetry or asymmetry within a distribution. So it shows the outliers in the distribution and their direction. Basically, it is usually caused by a heavily consistent activity with one range and less so in the other range. So there are two types of skewness: positive skewness and negative skewness. These are the parts of asymmetric skewness data, distribution data. So basically, positive and negative skewness is usually found by analyzing data set, because situation usually have data points from both extreme of the spectrum, and the asymmetric distribution basically causes skewness to be a part of the analysis. So skewness is basically how much the data set deviates from a normal distribution. A larger negative value in the data set mean the distribution is negatively skewed. So, and a large positive value in the data set means the distribution is positive. So basically it is good statistical measure that helps the investor to predict distribution return. So, as we all know, statistics play an important role when the data distribution is not normal. So, the extreme data points in the data set can basically lead data distribution to skew, or you can say it basically lead data distribution to skew towards the left, which means extreme data in the data set, or you can also say that, or it is skewed towards the left. If it is skewed towards the left, it means extreme data are large, that data set are positive, which result mean is greater than median and the mode. So basically it helps an investor with a short term holding period to analyze the data to identify the trend which are falling at the end of the distribution. So basically, so this is the basic meaning, or you can say the understanding of skewness. There are some points which we have understand from this skewness is that basically skewness demonstrate how many normal distribution of statistic data which is systematical on both sides, which are differ from reality also. If we consider a distribution that is skewed, basically it is neither systematic nor regular. It denotes a left or right skewed frequency distribution. Skewness can be either positive or it can be negative, or you can say destructive. Basically, skewness display how far the data set stray from the expected distribution. So the data set indicates that a substantial negative number, or you can say negatively skewed the distribution. So basically, when data set also contain a vast positive value, it is suggested that it is a favorable distribution. So we can also say that it is a super statistical tool for forecasting investor distribution return. So we can also say that there are various advantages of negative and positive skewness through the with the help of the discussion which we have done. We can say that skewness basically is better for measuring the performance of investment return. Basically, skewness helps the investor to use it when analyzing the data set, as it consider the extreme of the distribution. Basically, skewness has widely used in statistic, as it helps understanding how much data is asystematic from the normal distribution. So, as there are some advantages of uh, the skewness, so there are some disadvantages also of skewness distribution. The disadvantages of skewness distribution is that the skewness range from negative to positive infinity. Sometimes basically it becomes difficult for an investor to predict the trend in the data set, as it range from negative to positive infinity. So, when an analyst is forecast the future performance of an asset using the financial model, especially, which usually assume that data is normally distributed. But if the data distribution skews, this model will not reflect the actual result in the assumption. So these can be some disadvantages of skewness or skewness distribution. Now let's discuss the types of skewness. as skewness have are of two type: systematic skewness and asystematic skewness. So systematic skewness is also known as zero skewness, and asystematic skewness is further or is of two types: positive skewness and negative skewness. So if we have to tell types of skewness, then we can say that there are three types of skewness: zero skewness, positive skewness and negative skewness. So zero skewness is a systematical skewness, and positive skewness or negative skewness are a systematic skewness. Now let's discuss systematic skewness and the systematic skewness in detail. What is the basic difference between systematic and asystematic skewness? So, first let's understand systematic skewness. So, what is systematic skewness? When mean is equal to median and it is equal to mode. That is systematic skewness. So we can say that systematic distribution is one in which frequency distribution is the same on the side of central point of frequency curve. So the central point is mean is equal to median and is equal to mode. So there is no skewness in perfectly systematic distribution, or you can say in zero skewness. If we have to understand with the help of diagram, then we can say that systematic skewness is that in which that the frequency distribution so the frequency distribution is the same at the center point. So we can say that as it is not proper, so this is the center point. Okay, what we can say, this is the center point. So this is systematic skewed. What is this? This is systematic skewed. So mean, mean is equal to median and is equal to mode. Okay, this is also in this mean is equal to median and is equal to mode. So there is no skewness in a perfectly systematic distribution. There is zero skewness. Means it distribute the data frequency distribution, it distribute the frequency curve equally on both sides. Means this is the center point where mean is equal to median and it's equal to mode. So the distance from this center point towards the left side and towards the right side is equal. This curve is equal towards the left side and towards the left side. So basically this is systematic skewness. Okay, so this is systematic skewness. Now let's understand. Let me first erase this. So now what is a systematic skewness? Systematic skewness is, I hope everyone is understood about this systematic skewness. Now a systematic skewness. So a systematic or skewed distribution is one in which the spread of the frequency is differ on both side of the central point. As in systematic skewness, the distribution of frequency on both the side of center point is equal. But in a systematic skewness, the spread of frequency is different on the left side and the right side. So it is spread the frequency. You can say that in skew distribution is one in which the spread of frequency is different on both the sides of the central point, or you can say, or the frequency curve. It is more stretched toward one side, either the left side or either the left right side. Okay, so this is a systematic skewness. There are further two type of a systematic skewness: positive skewness and negative skewness. Positive skewness and negative skewness. Positive skewness is also known as right skewed, and negative skewness is also known as left skewed. So let's first understand what is positive skewness. Okay, so as in this concept, the concentration of frequency is more towards, or you can say, is more toward high value of the variable. Example, you can say that the right tail is longer than the left tail. So we can get a positive skew distribution for which mean, median, and mode are not equal. Okay, so the tail of on the right side of the distribution is longer or fatter, or you can say the mean is greater than the median. What is in positive skewness, mean is greater than median and median is greater than mode. Basically, let me explain you how it will work. So in this, mean is greater than median and median is greater than mode. Okay, so if we have to draw the diagram of this positive skew, then from this diagram we can say that this is a left tail. It is a left tail. So as you can see in this curve, or you can say, as you can see in this normal distribution curve or frequency distribution curve, the curve is left tail, which means value of mean is greater than median, and value of median is greater than value of mode. Okay, that's why it is positive skewed, and it is a part of a systematic skewness. Okay, so if we have to understand it with the help of example, we can say that let's consider an household income for an example. So household income distribution, most people earn around a median income. Okay, so but a few individual in a family earn significantly higher income, which create a long right tail. Okay, so if in a family or in a household there are six members are earning, and out of six members, two are earning medium income and other four are earning high income, so it create a longer right tail. What it create? It create a longer, longer left tail. It create a longer left tail. Okay. Next, negative skewness. We can now negative skewness. So let's first understand the meaning of negative skewness. So in this negative skewness, in this the concentration of frequency is more basically towards the lower value of the variable. in which the left tail is longer than the right tail. What is in this? The left tail is longer than the right tail. If the left tail is longer, we get a negatively skewed distribution, which means mean is lesser than median and median is lesser than the mode. So basically in this, mean is lesser than the median and median is lesser than the mode. So the diagram for this is different, or you can say it is opposite than the positive skew diagram. So basically in this, so this is how this is negatively skewed. The tail on the left side of the distribution is longer or the fatter, in which mean value is lesser than the median value. Okay, and it is lesser than the value of mode. So the mean is lesser than the median and the tail on the left side of the distribution is longer, or you can say it is fatter. So let's understand it with the help of an example. As an age at retirement, most people basically retired at the standard age, but a few retirements significantly occur earlier, which create a long left, you can say a long left tail. As in previous one, in positive skewness, the positive skewness create a long right tail. Similarly, negative skewness create a long left tail, okay, which is slightly fatter towards the left side. So as there is a standard age of retirement, as you can say, the 70 is the retirement standard age of retirement. But some people, like you can say in army, some people can take a voluntary retirement at the after the job of specific period. Okay, so this type of example, or this type of few retirement which can occur early, they can create a long tail, longer left tail in a frequency distribution curve. So this is these are the types, basically types of skewness: systematic and asystematic skewness. And there are further two types of systematic skewness, which is positive and negative skewness. And systematic skewness is also known as zero skewness. Okay, so this is how so now the concept of skewness is understood. Now let's come to the next part, which is measures of skewness. So there are two measures of skewness basically: absolute measure and relative measure. So what is the use of measuring skewness? Why it is important? So basically, measure of skewness help us to know to what degree and in which direction, it can be positive direction or it can be negative direction, the frequency distribution has a departure for symmetry. Although positive or negative skewness can be detected graphically, and depending on whether the right tail or the left tail is longer, which is positive skewed or the negative skewed, we don't basically get idea of the magnitude. So beside the boundary line, case between symmetric and asymmetric may be difficult to detect graphically. So there are some statistical measures are required to find out the magnitude of lack of asymmetry. So the use of measuring skewness is important because sometimes it is very difficult to understand the skewness of data with the help of graph. So a good measure of skewness should possess some, basically it possesses some criteria. So the criteria it follow for good measure can be, it should be unit free number, so that the shape of where you can say different distribution as you can say symmetric is concerned, can be compared if the unit of the underlying variable are different. So if the distribution is symmetric, the value of the measure should be 0. Similarly, the measure should give a positive or negative value. It totally depends on the distribution. According to the distribution, it have the positive or the negative skewness respectively. We can say that as we move for extreme negative skewness to extreme positive skewness, basically the value of the measure should vary accordingly. So measure of skewness can be both absolute as well as the relative measure of skewness. As since in a systematic distribution, mean, median, and mode are identically same, or you can say the median is equal to mean and mean is equal to mode. You can also say that in systematic distribution, mean, median, and mode are identically more. The mean moves away the mode, the larger the asymmetric of skewness. But in an absolute measure of skewness, you can say cannot be used for purpose of comparison because of the same amount of skewness as different meaning is in distribution with small variation and in distribution with large variation. So for measuring skewness, there are two methods, basically absolute measure and the relative measure. So in absolute measure, we can say we can calculate the value of skewness, which is denoted by Sk, is equal to mean minus median. Okay, mean minus median. So for comparing the series, we can not, we do not calculate these calculation or calculation which is absolute measure. We calculate the relative measure which are basically called the coefficient of skewness. Coefficient of skewness are pure number which are independent of the unit of measure. So basically, in relative measure, the method we used are first, let me tell you the simple meaning of relative measure of skewness. So, in order to make a valid comparison between skewness of two or more distribution, we have to eliminate the distributing influencing of variation. So, such elimination can be done basically by dividing the absolute skewness by the standard deviation. Okay, when we divide absolute skewness by the standard deviation, that is relative measure. Okay, so for relative measure, the first method is beta. This is beta or and y, beta and beta and y coefficient. What is this? This is coefficient. Okay. Next method is Carl Pearson. What is the method? Next one is Carl Pearson. Okay. Next one is Carl Pearson's coefficient of skewness. So we talk about the formula. So this is basically Carl Pearson's coefficient of skewness. Okay, this Carl Pearson coefficient of skewness, and after that there is Cayley's. Third one is Cayley's coefficient of skewness. Okay, as so this is the next method. First is beta y coefficient, then Carl Pearson's coefficient skewness and Cayley's coefficient of skewness, and the fourth one is Bowley's coefficient of correlation. What is this? Bowley's coefficient of correlation. It is not correlation, it is skewness. Okay, skewness. So first one is beta and y coefficient of skewness, Carl Pearson coefficient of skewness, Cayley's coefficient of skewness, and Bowley's coefficient of skewness. So these are the four method of measuring relative measure of skewness basically. Okay. So so we can say that in skewness that the value of mean, median and mode are same in any distribution. Then the skewness does not exist in the distribution. If there is large the difference in these value, mean, median and mode, then there is large the skewness. So if the sum of the frequencies are equal on both the sides of mode, then skewness does not exist. Okay. So if the distance, you can say the first quartile and the third quartile are same as we draw in this diagram, which I have told. So basically, this is Q1 and this is Q3, okay, and this is Q2, which is median also. So if the distance of first quartile and the third quartile are same from the median, then the skewness does not exist. So similarly, if decile the first and the ninth and decile are on a equal distance, and the percentile first and 99th percentile are at equal distance from the median, then there is no asymmetry. Okay, so as we have already discussed in quartile, percentile and decile also, so as let's understand with this quartile. So Q1, Q2 and Q3, so the distance of this and the distance of this should be equal. Okay, so then there is no symmetry, or you can say though there is no asymmetry. Okay, if this there is an equal distance of Q1 and Q3 from median, then there is no asymmetry. Okay. So we can say that if the sum of positive and negative deviation obtained from mean, median, or you can say mode are equal, then there is no asymmetry. Okay, so if there is a graphical data uh, become, or you can say it is a normal curve, and when it is fold to middle and one part overlap fully on the other, then there is no symmetry. Okay, so this is the understanding which we got from the skewness. Now, after understanding the skewness, we will understand the concept of curtices. What we understand now, let's understand the concept of curtices. Okay. Now, after that topic, previous topic, which is skewness, let's come towards the next topic of which is curtices. So basically, curtices is a statistical measure similar to skewness. It is used to describe characteristics of a data set. Similarly, like in skewness we did, when normally distributed data is plotted in graph, basically it generally takes the form of a bell. Okay, it will take a bell shape. Uh, we will later understand with the help of example. So this is also called, Curtis is also known as the bell curve. Okay, so the plotted data that are farther from the mean of the data, usually from the tail on each side of the curve. So basically, curtices indicates how much data reside in the tail. It is also characteristics of frequency distribution. It gives an idea about the shape of frequency distribution. Basically, it measure of curtices in the extent to which a frequency distribution is peaked in a comparison with the normal curve. So it is also a degree of peakness of distribution of data set. Okay, it is also known as bell curve, and it is also a degree of peakedness of distribution. Okay, so basically, curtices is measure of combined weight of a distribution tail relative to the center of the distribution curve, which is mean. Basically, we can say that when a set of you can say set of normal data is graphed by with the help of histogram or the another graphical representation, it show a bell peak with most of the data reading with the three standard deviation, which is plus or minus of the mean. So however, when high curtices is present, the tail extend further than the three standard deviation of the normal bell curve distribution. So basically, we can say that curtices is sometimes confused with a measure of the peakness of a distribution. Curtices basically is a measure that describes the shape of a distribution tail in a relative to the overall shape. A distribution in curtices can be sharply peaked with low curtices, and a distribution can have a lower peak with the high curtices. So basically, curtices measure tailness, not peakness. Okay. So distribution with the large curtices have basically, we can say that it has basically more tail data than the normally distributed data, which appear to bring the tail in towards the mean, or you can say distribution with low curtices have fear tail data basically, which appear to push the tail of the bell curve away from the mean. So if we talk about the types of curtices, then they are of three types, basically leptocurtic, mesocurtic, and uh, platycurtic. Okay, so curtices basically describe the fatness of the tail, which is found in probability distribution. So there are three types of curtices: mesocurtic, leptocurtic, and platycurtic. Mesocurtic is normal. Platycurtic is basically less than normal, and leptocurtic is more than normal. Okay, so courtesies basically risk is measure how often move toward investing price move dramatically. Okay, so the curve of courtesies characterized tell you how much courtesies risk there in the investment you are evaluating. If you are investing in something, then a curve of courtesies is help you in evaluating the risk basically. Now there are three type of courtesies. This is the graphical representation of courtesies, types of courtesies. First, let's understand what is leptocourtesies. So basically, leptocourtesies is a curve which is having the high peak than the normal distribution. As high peak than the normal distribution curve. So in this there is much more concentration of item near the central value. Okay. If we talk about the mesocortices, so mesocortices is the curve which is having normal peak. Okay, which is having normal peak than the normal distribution or normal curve. It is basically called. This is not normal peak. Okay, so this is mesocortic and this is plateaucortic and this sorry lepto and this is plateaucortic. Okay, so in mesocortic, there is a equal distribution of item around the central value. Okay, there is a equal distribution around the central value. Understood? Now plateaucortic. So basically, plateaucortic is a curve which is having a low peak than the normal curve in a that is called plateaucortic. In this, there is a less concentration of item around the central value. This is the curve of plateaucortic. So this is leptocortic, this is mesocortic, and this is we can say plateaucortic. Okay. So this is how we can graphically represent types of cortices. Okay, so which have the highest peak is leptocortic, mesocortic is the normal curve or normal peak, and plateaucortic have the lower peak. Okay, so basically, cortices measure the heaviness of the tail and peakness of the distribution. A normal distribution have three cortices. We have already discussed plateau, mesocortic, and leptocortic. Any deviation from this value can indicate the degree of departure from normally. Okay, so cortices basically help in identifying whether our data set have more or fewer outlier, and this say shape basically the shape of the distribution. Okay, so this is the So, this is the concept of courtesies. So, we have already discussed skewness and courtesies. If we have to differentiate the concepts of skewness and courtesies, then we can say that skewness basically indicate the shape and size of variation on either the sides of the central value. Okay, and kurtosis basically indicates the frequency of distribution of the central value, or you can say at the central value. Okay, so skewness basically measure difference of skewness, tell the magnitude and the direction of asymmetry of the distribution or the frequency curve. And in kurtosis, it indicates the concentration of items at the central part of a distribution. Uh, Basically, skewness indicates how far the distribution differ from the normal distribution. Okay, and in kurtosis, basically it studies the divergence of the given distribution from the normal distribution. Okay, if we talk about the skewness, so skewness. In the measure of skewness basically study the extent to which you can say deviation basically clusters is the above or below the average. But in kurtosis, it indicates the concentration of item basically. So, this is the major difference as both skewness and kurtosis describe the shape of distribution. Okay, there is a basic difference is that they both describe the shape of distribution. Okay, so this is the difference of skewness and kurtosis.